Hello, this is Ms. DB. In this video, we are going to work on the Solve Quadratic Equations by Graphing worksheet. So we're going to solve quadratic equations, and we're going to use graphing to do that. There's different methods that we'll learn about, and this is just one of them. And we will find the roots, which are the x-intercepts, and the vertex from a graph of a quadratic function. I have Desmos open because I'm going to be using that to complete some of these problems. So there's an example here that says how to find the zeros. The zeros are where the parabola is the name of the shape you get from a quadratic function, and the zeros are the x-coordinates of the x-intercepts of the graph, so where it crosses the x-axis. So that's when y equals 0, so that's why they're also called the zeros. And they're also called the solutions, so they have lots of names, and they're also called the roots. So we're going to graph these, and some of them will be decimal numbers, so it says round to the nearest tenth. And I wrote in the directions that you can graph with technology and attach a screenshot or a link to your graph. And then I also said make sure that you adjust the scale of your graph. Like over here, I probably will not be using this scale because it goes too much. It's 20, 40, it's too wide of a scale. And the y-axis also. I'm not going to be able to see where the x-intercepts are very well with that scale. So I'll show you how to do that. So let's just pick, let's just do the first one here. Y equals, I'm going to type this in, x squared plus x minus 6. Now if it's y equals, I also could change, I could just type in the part after the equal sign. But there's nothing wrong with putting it in there, it doesn't change the graph. Here's what I was talking about. This is really skinny, and I can't tell what the x-intercepts are from this graph. So I'm going to change this. Now I could just zoom in, but now I've like lost some of the value of it. So here's how to change it if you don't want to just zoom in. I can change the x-axis to include like maybe -10 to +10. And my y-axis does not need to have all of these negative numbers. I'll go from like -6. Oops, that's -61 to, I don't know, I'll go to 30 because you know quadratic functions grow really fast. And that was pretty good. I can see most of what I need to see. You can also click on the x-intercepts in Desmos, and it will actually tell you exactly what those values are, even if they're decimal numbers. You can also find the vertex if you need that. You can also see the y-intercept if you need that. So Desmos is great about giving you many of these important values that we might need in our question. So in these problems, you only have to find the solutions, but if I needed more information, I certainly can find it here. So to add your graph to your answer for number 1, there's a couple different methods. In a Windows computer, you can use what's called Snip and Sketch to get a picture. So that's what this is here, and I'm going to click New, and then I can draw a box around the graph, and I'm going to include the function as well. That's a good way to check that you have the right equation typed in. And then I'm just going to copy that, and then here on the worksheet, I'm going to click right underneath number 1 and do Control V on my keyboard. And there's the graph. It's pretty big. I'm going to make it a little smaller. I don't need to see that much of detail. And there's the graph for number 1. I could make it bigger though. It's just a Word document, so it doesn't matter if you're taking up a lot of pages, right? I could also, or instead of, get a link to the graph. So here's the Desmos page again. Right up here, you can share a link to your graph. So here it is. I just have to click copy, and then over here I'm going to click Control V again and hit the space bar so that it turns blue. That means that I will be able to click on the link when I grade your work. Now, I didn't actually answer the question. The graph is great. I have to attach the graph, but I also have to answer the question, where are the roots or the solutions to this quadratic equation? And the answer to this would be -3 and 2, because it crosses the 3, and at 2. If you want to put the coordinate points, -3, 0, and 2, 0, that's fine too. Either way is fine. And then when you move on to the next one, you will do this the same way. In the next section, it says to find the root solutions of the following quadratic functions by graphing. You do not need to attach your graph, so just name the roots. But you still need to make the graph in order to find the answers to these questions. We will learn in future assignments how to solve these different ways by factoring, by using the quadratic formula, and by some different ways. So let's just do another one. Let's do number 9. Number 9 says y equals -x squared, and you can use this to square the x, or you could use your keyboard to do that. So there's the x squared button, minus 10x, oops, not z, x minus 25. So then I just double check. Yep, that's everything I need. And this one only has one solution, or one root. It only crosses the x-axis at one point. It actually just touches it, but that is a solution. So for this section, you don't have to put the graphs in here, so I can just write that the solution is -5. And then it says round to the nearest tenth. I didn't have to for any of these other ones. Let's see if I can find one that might have a decimal, so you can see. Let's try this next one. 2x squared minus 3x. This one has decimal. One of them's a decimal, and you don't have to round it because it's just going to show up for you. So remember, the solutions are where it crosses the x-axis. So when you're doing numbers 6 through 10, you can put them on the same page. You don't have to attach it. You could even just turn off the one so you can just focus on that one. And then you can zoom in as needed or click to find the solutions to your quadratic function. Okay, in the next section, you're also going to find the roots. You're going to find the roots again and the vertex, and you don't have to attach your graph. So this is not one from this section, but if I were to find the vertex, this is the vertex, and you would type in that exactly, even though, yes, it does have decimal numbers. There's nothing wrong with typing those in. So don't round those, just type in exactly what you get for the vertex. For example, in this one, this is using Desmos, and I graphed, and I found that for my vertex. This one did not have any roots, this number 12 that I had done for you on the worksheet, because it does not cross the x-axis. And that happens sometimes. And we'll explore more about that in future assignments as well. I'm just going to type in these two from number 16. So let me get rid of these. So in number 16, it says graph y equals 2x squared minus 4x plus 8. So that's this graph here. And also y equals x squared minus 2x plus 4. It says graph them both on the same screen. Find the roots and vertices. Now this is very important that you have a good scale of your x and y axis. This is good because I can see that they are not crossing, neither of them are crossing the x-axis. So something that's the same about these is that neither of them have any roots. So that's interesting. Neither of them will cross the x-axis. This one has a vertex of 1, 3, and this one has a vertex of 1, 6. So both of the vertices have an x value of 1. And then it says, how are the two equations related to each other? Hint, factor them. Let's factor each of these. We worked on factoring earlier, and we're going to keep practicing working on factoring. So my first one is 2x squared minus 4x plus 8. And if I factor that, I first want to factor out the greatest common factor, which would be x squared minus 2x plus 4, because the greatest common factor is 2. And then I could factor that as x minus, I don't know if I can, maybe I'll just leave it like that for now, because now look at, I factored out the greatest common factor. I don't think there are any factors of 4 that when you add them to -2, so this is as far as I can factor. But that's the exact same thing as this one. So the 2x squared minus 4x plus 8 was this one, and then the other one was wider than that, wasn't it? So by multiplying by 2, it actually made the graph skinnier. The vertex also moved, but it made the graph skinnier. So we can see that this one has been moved up, and it seems narrower than the other one. So that's something that you can write for how they're related to each other. And the first is, here I'll write the second function, whoops. Okay, I can't type. So here's a question. Is the first one really skinnier, or is it just moved up and therefore looks skinnier? Because if I had just moved that one down, then they would be right on top of each other. So it's moved, but it's not really skinnier, is it? And then you can do, you're just exploring. These questions won't necessarily have a right or wrong answer. The main thing is that you're exploring them and answering the questions about them and thinking about it. And then there's one more problem, real world problem about throwing a ball, very standard quadratic function problem. And this is the equation about the height of the ball with respect to time, where t is time. When you graph this, you have to replace t with x because Desmos isn't going to use x as a variable. So make sure you replace the t with x's, and then you can see a nice graph. This graph is not good because I can't see all the parts of it. It's just real skinny, and the vertex is way up there. So I'm going to change the scale using this little thing, and I don't want my x to go all the way up to 24. I want it to go like 5. I only need from like 0 to 5. And my y-axis needs to go a little higher. I'm going to go up to like 70. All right, now look what a nice graph that is. I can see where it's crossing. Here's where you throw the ball up. The negative parts below the x-axis don't make sense because that would be if you were in a hole throwing it up and then the ball goes through the ground when it lands. That's pretty strong. So really, I'm starting here. I'm going up. This is the maximum height. This is time down here. So at before 2 seconds, at in fact 1.875 seconds, it reaches its maximum height, and then it comes back down and it hits the ground at this many seconds. So that's how you would use this, how you would use the graph to answer these questions. All right, thank you very much. Let me know if you have any questions.